All right, this is 8-5. Our purpose statement is the student will be able to explain and describe the steps to solve rational equations and inequalities by completing page 605, numbers 19 to 45, the odds. So that's going to be your assignment. Today we've been working with simplifying. We did multiplication, division of rational expressions, and then we did addition and subtraction where you had to find the common denominator. Today's kind of a combination of the two. So we went over this definition earlier in the year, but an extraneous solution, remember, is a solution of an equation derived from the original equation that is not a solution of the original. So in other words, what that means is if you do the problem, you're going to get some answers. Well, sometimes you have an extraneous solution that works in the equation but doesn't work in a story problem or in the solution. Example of this might be when we get a answer that says our answers are 2 and 5, but we had in the denominator x minus 2, so remember our restrictions would say x cannot equal 2, so that would cancel out that answer. Another thing might be like we're going to do some story problems today, and let's say that you're talking about speed, and one answer is positive and one answer is negative. Well, the speed of anything is not going to be a negative number. It can be really slow, but it can't be negative. So those would be extraneous solutions. They work in the equation, but they don't work in the problem. So mainly what we're going to be doing today is solving rational equations. So we're doing the same thing, except now we have an equal sign. And so we have a special tool we can use that allows us to solve equations that we couldn't use when we do multiplication, division, addition, subtraction. So the first thing we're going to do is we're going to find the least common denominator. So if we took as an example that we were doing this problem, x plus 8 over x equals 6, and we were to find the least common denominator. Now, x and 6, even though they're not fractions, those would technically have 1s underneath them, but we don't need 1s when we find the least common denominator. So the only factor we have in the denominator is x, so our least common denominator is x. So in this case, we found our least common denominator, and it's x. Then what you want to do, and you can only do this when you have equal signs or inequalities, you want to multiply every term by the least common denominator. And if you do this, this will always eliminate all the fractions. So we'll get rid of the fractions that you don't like to work with anyway. So we're going to take this expression, x plus 8 over x equals 6, and we're going to multiply the whole thing by that least common denominator. So I'm going to take this and times it by every single term. So, two ways you can do this. If you want to do it in your head, that's the way I usually do it. But x times x is x squared. And then here when I multiply this, well, I have an x in the numerator and an x in the denominator, so those cancel. And we just get plus 8 equals 6x. Now, some people that like to physically do things and it helps them keep track of it better, they'll put that times x like this with every term so that they can actually go through and x times x is x squared. Here the x's cancel so that they can physically cancel that. You don't want to do that if you do it mentally because then that x wouldn't be there anymore. And then x times 6. So if you like doing that, then by all means do it. You don't need to. So now that we've multiplied by the least common denominator, you can see we no longer have any fractions in this problem. So then we solve for the variable. Well, this is a quadratic, which a lot of the stuff you'll be working with today will end up as a quadratic. So we set a quadratic equal to 0, so I'm going to subtract 6x from this side. And so we get x squared minus 6x plus 8 equals 0. Then you can factor that or use the quadratic formula. But that factors into x minus 4 and x minus 2. And so then again, you can set these equal to 0, or the shortcut is the opposite of this divided by the number in front. So my solutions would be 4 and 2. And then our last thing is we want to check the restraints for extraneous solutions. So that, remember, our restraints are what x can't be, because they make the denominator 0. Well, in this case, my restraint would be x cannot equal 0. Since 0 is not one of my answers, we don't have to cross anything out, and the solution would be 4 and 2. So let's do one more of these. Let's do 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. So again, our first step is find our least common denominator. So we want to factor these denominators if we can, which we can't factor that, can't factor that. So now remember, when you find your least common denominator, you take every single factor. I have 1x minus 7 here, none here, and 1 here. Remember, for your least common denominator, you need the most that occurs in any single denominator. So I have 1 here and 1 here, so I have 2, but the most that I have in any denominator is 1. So I need 1x minus 7. Then I have 1, 2 here, none in either of the others, so again I need 1, 2. So that would be my least common denominator. So now I'm going to come back to this, and I'm going to take multiply this all by that least common denominator, 2 times x minus 7. So again, I take and multiply that times each term. Here, the x minus 7's cancel, so I get 2 times 2x minus 9. Here the 2's cancel, so I get x times x minus 7. And here the x minus 7's cancel, so I get 5 times 2. So now I'm going to simplify this, distribute the 2, 4x minus 18 plus, distribute the x, x squared minus 7x equals 10. Combine like terms, I have x squared. 4x minus 7x is a negative 3x. I'm going to move this 10 to the other side by subtracting it. So I get minus 28 equals 0. Now again, you would use the x method, but this factors into x minus 7, x plus 4. And so my answers are the opposite of this divided by that. So we get 7 and negative 4. Check the restrictions. If I go up here, x minus 7, remember, cannot equal 0. So x cannot equal 7. So that eliminates that possibility. So my answer would just be x equals negative 4. So most of the work you're going to be dealing with is stuff of this type, even the story problems. But you will have some inequalities to work with. So less than or greater than signs. So I'll do a couple of those. To solve steps to solve inequalities, it's the same as solving equations, except you must consider the fact that your LCD, least common denominator, could be positive or it could be negative. And remember, when you multiply by a negative, you have to flip the sign around. So therefore, you must solve the equation twice, once as if the denominator is positive and once as if it's negative. So a lot to that you'll see as we go through the problems. So third example we'll go over is x over x minus 4 is less than or equal to 2. So we have to do this two separate ways. We have to do it as if x minus 4 is greater than 0, because that would mean it's positive, or as x minus 4 is less than 0, because that would be, so this is when it's positive, and this is when it's negative, if it's less than 0. Now it's an or statement because it can't be positive and negative at the same time. All right? So now, if I was to solve this, we know that x is greater than 4 by moving the 4 over there, and now I solve this problem just like I did when it was an equal sign. So my common denominator in this case is x minus 4. So I multiply that times both. Here the x minus 4's cancel. So if I was to solve this, I would get x is less than or equal to 2 times x minus 4. So that is x is less than 2x minus 6. Minus 8. I'm going to move the x to this side by subtracting x, and the 8 to that side by adding 8. So I get 8 is less than x. So this is an and statement because x is greater than 4 and x is greater than 8. Well, if you looked at that at a number line, we have 4 and we have 8. This would be open circle, and this I guess would be less than or equal to. So this would be x is greater than 4, and this would be x is greater than or equal to 8. Well, remember, an and statement is only what makes them both true. The only thing that makes these both true is x is greater than or equal to 8, because like 5 is greater than 4, but it's not greater than 8, so we don't include that. So now I go over and I do this one. So this would be, add 4 to both sides, x is less than 4. And now I do the problem over again. I multiply by x minus 4, so I get x. Now, since this is a negative, that flips the sign around. So really everything stays the same. I do everything exactly the same. Subtract the x and get x, move the 8 over here. So now I have, again, that x is less than 4 and x is less than or equal to 8. So again, if you look at the number line on this, we're at 8 and 4. And this is less than or equal to 8, so this way. And this is less than 4, so this way. And remember is the overlap, so that would be x is less than 4. We wouldn't include this part here. And that is an or in between these. So now I know for my final answer that x, and there's a couple ways you can just leave it like this. 8 is less than or equal to x, or greater than or equal to x, or x is less than 4. You can put the less than first, it doesn't really make any difference. Kind of switch that around so the x is on the left. It doesn't make any difference how you write that. They don't ask you to graph it, but some people like to look at it on a graph. So 4 and 8. So this would be a closed circle at 8 and an arrow to the right, and an open circle at 4 and an arrow to the left. It's possible on some of these that only one will work, like you won't have a possibility over there. But that's how you do an inequality. So we'll do one more of those. Hopefully that will help clear it up. Second problem, let's do x over x minus 3 is greater than or equal to 4. So again, we have to do it as if it's positive and if it's negative. So it's positive, x minus 3 is greater than 0. So x has to be greater than 3. And this one to be negative, x minus 3 would have to be less than 0. So x would be less than 3. So now we do this both ways. Our common denominator in this case is x minus 3. So this, the x minus 3's cancel, and I get x is greater than or equal to 4x minus 12. I'm going to move the 4x over here by subtracting it, so I get negative 3x is greater than negative 12, or equal to. And then I divide by negative 3. Remember, if you divide by a negative, you must flip the sign around. So we have, in this case, that x is greater than 3, and x is less than or equal to 4. So that means that x is, if it's greater than 3, and, because remember this is an and statement, and is less than or equal to 4. So it's between those two. Now when I do it the other way, again my equation is going to stay the same, except because I multiplied by a negative, I'm going to flip that around. And so now I get this negative 3x is less than or equal to negative 12, and then I divide by negative 3, and I get x is greater than or equal to 4. And so here I have, if you look at this, I have that x is less than 3. Remember, this is an and statement. X is greater than 4. Well, if you look at a number line, x is less than 3 goes this way, and x is greater than or equal to 4 goes this way. And is the overlap. There is no overlap over here. So there's nothing over here. This is no solution. And now I've got these two answers. Well, it's either this or that, so this would be my answer. So you can have it, on that last one, we combine these two. Well, in this case, it's just this one, because there is no solution over here to add to this. So that's inequalities. The other thing we're going to do on this assignment is we're going to do story problems. And one type of problem we're going to do is looking at, we can look at speeds of things. So in this case, we've got one problem that says that we have this person that is going to start here at this point, and they're going to row in a canoe upstream, okay, for 3 miles. And then they're going to come back downstream the same distance. And we know that the total trip takes 4 hours. And they want us to find out the speed of the current. Okay? So, this is a distance problem. Distance, if you think about it, if I ask you if you're driving 60 miles per hour and you drove for 3 hours, you could tell me that you'd gone 180 miles by taking the speed times the time. So we have a formula that says distance equals rate times time. In this case, though, we have some things that we don't know. If we look at the distance equals rate times time, we have upstream and we have downstream. Two different things. We do know the distance is the same in both, 3 and 3. And we know the rate, well, when you're going upstream, oh, and we also know in this problem that the person rows at 2 miles per hour in still water. So if they were on a lake, their average speed would be 2 miles per hour. And so we know that their rate, if they were in still water, would be 2, but since they're going upstream, we have to subtract the speed of the current. And we don't know how long it takes because we know the total trip time. We don't know upstream and downstream. We would know that upstream would be slower than downstream. Coming back, we know the rate would be 2 plus c times, again, the time is going to change. So we have this information, but we have two variables which cause us a problem. But we can look at the total trip. We know that the total trip time, remember, is 4 hours. Well, that 4 hours, the way we get the 4 is we add up the time for trip 1 plus the time from trip 2. And now we can solve for T1 by simply dividing by and then dividing by 2 plus c equals T2. And so I can substitute those values in for T1 and T2. So 4 equals, T1 is 3 over 2 minus c plus 3 over 2 plus c. And now it's just like the other problems. Our common denominator would be 2 minus c and 2 plus c. So I have to take those times all the terms. So I get 4 times 2 minus c and 2 plus C equals, here the 2 minus C's cancel, so I get 3 times 2 plus C, plus, here the 2 plus C's cancel, so I get 3 times 2 minus C. And now we can solve this. So I'm going to multiply these together first. Again, you're clawing it, but they're conjugates, so we get 2 times 2 is 4, and then we get a positive 2C and a negative 2C, which will cancel, and we get negative C times C is a negative C squared. Equals, distribute the 3, 6 plus 3C, distribute the 3, 6 minus 3C. So on this side, I'm going to get 16 minus 4C squared equals 12, and the 3C and the minus 3C cancel. Subtract 16. It's a quadratic, but since I don't have a C, I don't need to move it over there in factor. I can just solve for C squared. Negative 4C squared equals negative 4. Divide by negative 4. And we get C squared equals 1. And so C equals the square root of both sides. So plus or minus 1. But remember, this is a story problem. So right now we've got 1 and negative 1. But is it possible for the current to be a minus 1 miles per hour? Well, no, because if it was minus 1, it'd have to be going the wrong way. The other thing you should check, so our answer in this case is 1 mile per hour for the current. So current equals 1. The other thing you should check on your answers to see if it makes sense. If we would have had an answer like 3 here, well, it wouldn't make sense in the problem because the person only goes at 2 miles per hour. So if the current's at 3, they'd be going downstream and they'd never go upstream. And so you want to check and see if your answer makes sense. So that's a speed problem. One other type of problem that we're going to work with is called a work problem, where 2 people are going to work together. And so what you have to look at is their work speed. So as an example, if I had, let's say Eric, and let's say Jill, and I said that I was going to have Eric paint this classroom over the weekend, and he told me that it would take him 6 hours to do it. And Jill, if he did it by himself, and Jill told me that it would take her, let's say, 8 hours to do the job. So we're going to be asked to find out, well, how long would it take them if they worked together? Well, with Eric, since he does the job in 6 hours, that means they're going to work now together. Well, the time they're going to work is going to be the same, and they're going to paint one classroom. But we have to look at their work rate. Eric does it in 6 hours, so that means he does every hour, 1 hour, he will do 1/6 of the job. So we're going to multiply his work rate times how long he works. So I'm going to write that as x over 6. Plus, Jill does it in 8 hours, so it means her work rate is she gets 1/8 the job done every hour. So we're going to multiply this by 1/8 and get x over 8. So now we have to find a common denominator. In this case, it would be 24. And we multiply everything by 24. So 6 goes into 24 4 times, so we get 4x. Plus 8 goes into 24 3 times, so we get 3x. And 1 times 24 is 24. So 7x equals 24. Divided by 7. So x equals 24/7 or 3 3/7. So it would take them, if they work together, 3 3/7 hours to paint the whole room. So you have to, when you do these work problems, you have to figure out their rate per hour times it by how long they're working. In this case, we didn't know how long they were working. So your assignment you already have. It is page 605, 19 to 45 the odds. Hope that helps.